Hello. It's a new day, a new chapter. The air is full of optimism. Welcome to chapter 5, where we're going to be doing polynomials and monomials and lots of great algebra. Let's get started. As always, when you start a new chapter, there's probably going to be some vocabulary words. So our first one of the day is a monomial. So a monomial is a number, variable, or a product of numbers and variables. So, for example, 4 is a monomial. 7x is monomial. 3x squared is a monomial. Things that are not a monomial, 3x squared plus 7x. This is not a monomial. That is a polynomial. We'll get to those later. But it's just the single thing. Notice how they are all multiplied together. So that's what we're going to talk about. We're going to talk about multiplying or product rules of monomials. So notice we've got an x, we've got an x squared. We are going to be messing with exponents a lot. So there are a couple of patterns that make exponents not that bad. So for example, we've got a product rule. So the product rule of an exponent, when I write it in mathese, we've got a, which is a number raised to the power of m, and a, which is the same number raised to the power of n, that is equal to a m plus n. Basically, when we're multiplying the same number to different exponents, you just add the exponents. Easy as that. So where we would see this is something like x squared times x to the 7th equals x2 plus 7 is 9. That's all. Okay, so we've got a product. I'm actually going to go straight to the quotient rule, so I'm coming down here. Yes, I'm skipping one, but our product, when we multiply those together, we add the exponents. So if we divide them, what do you think is going to happen? So in mathese, we got a raised to the power of m over a raised to the power of n, as in November. So up at the top of the product, we added them. When we divide them, it's just going to be the opposite, a of m minus n. So we would say that is a raised to the power of m minus n. For example, x to the 7 over x squared is equal to x raised to the power of 7 minus 2. So 10, 9, 8, 7, 6, 5. So x to the 5th. Okay, so now we're going to go back to the product rule because we can't leave that one behind. So what that one means, the power rule. What that one means is if we have a raised to the power of m and the whole thing is raised to a new power, that is the same as a m n. So those are multiplied together. The m and the n are multiplied together. So when the exponents, when you have a power raised to a power, those exponents are multiplied together. So for example, we're playing with 7s and 2s, so we have x squared raised to the 7th power equals 7 times 2, x raised to the 14th power. So that's how that one's going to work. Okay, so we've got the negative exponent rule. We're going to see this one a bunch as well. Actually, we're going to see all of these a lot, so let's get these down. The negative exponent rule, we've got a raised to the mth power. So that is the same as 1 over a to the m power. So notice how the negative sign goes away because it goes into the denominator. Now it works the opposite direction too. If the negative sign was in the denominator already, if it was 1 over a raised to the negative mth power, then you would switch that up to the denominator, the numerator. So long story short, this negative sign in the exponent just flips it to the other side of the fraction. Okay, so our example, we have x raised to the negative 2th power, or negative squared, whatever, is the same as 1 over x squared. Easy as that. Last but not least, everyone's favorite exponent rule. Take a, any number, raise it to the 0th power, that equals 1. And just for your record, except for 0. 0 raised to the 0th power is undefined. And that's because it's kind of bizarre to think about. You have 0 groups of 0 multiplied together. And so there's some weird math that goes along with that. But just know that 0 to the 0th power is undefined. More importantly, anything we have, 7x squared, raised to the 0th power equals 1. Easy as that. That's why we like that. It makes things cancel out. So this is what we're doing. So let's practice these rules. All right, let's do some examples. So looking at number 1, we've got all that stuff multiplied together. So step 1, I always like to multiply my numbers together. So 5 times negative 7 is negative 35. So now we've got our x values, x squared times x6. That's our product rule. We're going to add our exponents. So that means we got x, 6, 7, 8, raised power 8th. There's your answer. So if we move over to number 2, always do your parentheses first. So we've got a power raised to a power. So that's what we're going to start with. So this 2 is going to affect that negative 2 as well. So we're going to have a positive 4 because negative 2 times negative 2 is positive 4. So then we're just going to multiply the exponents. We have 2 times 3, so we have a to the 6 and b to the 2th, or squared. So then we're going to have times 8ab to the 9th. Okay, so that was our power rule. Now we have a product rule. I'm going to do my numbers first. 4 times 8 is 4 times 8, 32. I knew that. 32. A to the 6th times a is going to be a to the 7th. B squared times b to the 9th, 9, 10, 11, is b to the 11th. And there you go. Looking at number 3, it's a fraction. It's fine. We have a quotient rule that can help us out. Okay, so just like we did with the product, we're going to deal with our numbers first. That seems like it's going to be a number. So 54 divided by 3 is 18. And then, oh goodness, is 18. Oh my gosh. And then m to the 6th divided by m squared. 6 minus 2 is m to the 4th. N squared is in November to the 4th over n to the 1th. There's an implied 1 there. We're just going to have n cubed. Then we've got our 10m to the 4th n cubed. Okay, so we haven't really gone over this just yet, but you're going to see it no matter what. Anytime you have like terms, m to the 4th n cubed, m to the 4th n cubed, you can combine those like terms. So we're going to have 8m to the 4th n cubed. So I just took 18 minus 10. And then number 4. So again, I always like to start with the numbers or just move left to right. 2 times 10 is 20. K, ooh, they have a negative over here. So, okay, so that means that I can't do, yeah, I can. No, it's fine. So 2 times 10 is 20. K to the 4th is going to go on top. And then we're going to divide by k to the 7th. So that negative sign puts that k into the denominator. But because there's no parentheses like this negative 7 only hits that k. So, and then from there, we have k to the 4th, looks like a terrible 4, over k to the 7th. So we're going to have 20 times k to the -3. Yeah, to the -3, or we can just say k to the third underneath. So hopefully you're kind of getting the pattern, getting used to things. So try 5 and 6 by yourself and see what you get. So pause the video right now. And boop. Is that what you got? So we've got 2 over 27, r to the 7th, s to the 15th. And then over here we have 1 over 2, w to the 9th. So number 7 looks kind of scary, but it's not terrible. Again, once you just try to get used to those patterns. So we're going to start with our numbers first. It doesn't divide evenly, but we can at least take a 3 out. So we can reduce this fraction. So then we're going to have 5 over 8. Probably need more of a line. So then we've got x to the 10 over x to the 12th. So that means that's going to be 10 minus 12. So that means we're just going to have x squared underneath here. And then we've got y to the 4th minus y to the 3rd, or 4 minus 3, or y over y, whatever. So that's just going to be y to the 1st up top. So again, if you chunk it out piece by piece, it's not too bad. So then number 8, we can kind of do the same thing. So we're going to take care of this. So that's going to be 4 multiplied into there, 4 multiplied into there. So that means we're going to have c to the 4. Actually, no, back up. It's much easier to do this inside of the parentheses first. What we were doing is not wrong. This is just easier. So we're going to have 1 over c, and that's going to be raised to the 4th, times, we can go ahead and do this one because there's nothing inside that we can do. 3 raised to the power of 4 is negative, why is it? No, it's just 81. Almost had a calculator error. And then that's going to be c to the 4th. So since we're multiplying all that, this one, the term on the left is going to be 1 over c to the 4th multiplied by 81 c to the 4th, which all of that equals 81. No more c's. Okay, so our next vocabulary word is polynomials. So a polynomial is the sum or difference of many monomials. So this is where we get into like our normal equations that we're kind of used to seeing. Couple more vocabulary words. The highest exponent of the polynomial is called the degree. So you'll see things like, you know, a third degree polynomial or something like that. So is degree. So the highest exponent of the polynomial is called the degree. And then in standard form, it's kind of what you would expect. It's just going to be your biggest exponents first, and it goes in descending order. So I'm just going to put descending exponent order. So, you know, if it's like an x squared, it would be an x squared first plus x plus no x. So if we were to do a couple examples of just writing in standard form, you know, I look at number 10, 5 is my biggest, so I'm going to put negative k raised to the 5th power. And we don't care about negatives when writing in standard form. So I don't see a k to the 4th. I do see a k to the 3rd. Oh, there's a 3 there. K squared. 1/4 k squared. And for polynomials, it's okay to have fractions. And then we have a plus 8k and then minus 1. So hopefully you see 5, 3, 2, 1, 0. So they just go in order. Let's see. As we look at 11, okay, we could, let's say we had a b cubed. We could kind of debate whether to put the b's cubed, the b's first, or the a's first. Typically, if it's all things are equal, then we'll just go in alphabetical order. But either way, we've got a 3 here, which is our biggest exponent. So we're going to put 4a cubed. And then we've got a squared. So plus 18a squared b squared. From there, we've got, looking at my a's, we've got my a to the 1th, or just a, 7ab. And then, what do we have left over? We have a b squared. Yeah, just minus b squared. And last but not least, we've got 5x, x squared, x cubed. So we'll start with our x's. We are just going to go in alphabetical order. So 9x cubed y minus x squared plus 5xy squared. And then what do we have left? Minus y to the 4th plus 2. So what kind of ends up happening is all of our x's are focused on this side, higher orders of x's are on this side, and then our higher orders of y's are on this side, and it kind of transitions in the middle. And then we just always have our constants out here towards the right. So a couple more vocabulary words. This section is going to be heavy on the vocabulary words, but don't worry too much about them. I'm going to tell you specifically which ones that you should care about. So classifying polynomials, when we look at like the degree, so that is the biggest exponent that they have. So there's different words that go along with it. So let's say you don't have an x or a 0 degree. We're going to call that a constant. So that would be like y equals 3. 1x would be linear, which makes sense. If you have like y equals 1x plus a number, that's just a line. A second degree polynomial is a quadratic. You should be very familiar with quadratics. After that, it's a cubic, quartic, and quintic. If you can guess, the ones that I'm going to care about are going to be these 3, maybe a little of that one. You'll hear me say a cubic a lot, but these are the 3 that you need to know, just so that you can have a conversation with another math person and not sound like an idiot. But these are the constant, linear, and quadratic. Those are the words that you really should know what they mean. Also, if we have different sets of words, vocabulary, to tell you how many terms there are. So we've used the term monomial. Monomial. That's one term. We've used I think you've heard the term binomial before. So hopefully you know that that means 2 terms. Then we've got trinomial, like a perfect square trinomial. And then anything more than that is just a polynomial. So these are pretty important words to know because we'll be using that vocabulary over and over and over again. So it's good to know what we're talking about when we use those words. So if we go through all these examples, classified by degree and then number of terms. So 13, we're going to have a linear binomial. It's linear because there's only one x, and it's binomial because there's two terms. So then 14, we're going to have a quintic trinomial. So there are three terms, but then the highest degree is that guy right there. We're going to clean this up. And then going down, that 24 is our constant. And that is going to be a monomial. 16, our highest degree is 3, so we're going to call that a quadratic. No, just kidding. Our highest degree is 3, so it's going to be a cubic. And there's 4 terms, so we're just going to default to polynomial. 17 is a quadratic because there's 3. Because it's squared is the highest term, is the highest degree. There are 3 terms, so it's a trinomial. And then 18 is going to be another monomial. And because it's the 4th degree, it's going to be quartic. Again, these words on this side, I'm not going to test you on them, to be completely honest. These are just kind of sort of good to know if somebody throws them out. These words, I'm probably still not going to test you on them, but these words are going to be thrown around in class a lot, so you need to start getting comfortable with this type of vocabulary. Adding and subtracting polynomials, it's not terrible. All you're going to be doing is combine like terms. This is where the iPad comes in super handy because I can look at number 1 real quick and I can say, oh, there's an x squared, there's an x squared, let me change colors, there's an x, and then let me change colors. So you can color code, it's really convenient. But you're just gonna combine like terms, and since we're just adding the coefficients in the front. So x squareds, so we're going to have negative 2x squared. Notice how I'm starting with, that's wrong, 3x squared and then 1x squared. So we're going to have 4x squared. Notice how I'm starting with the square, the highest degree, plus 11 minus 5 is 6x. And then last but not least, minus 9. So let's do the rest of these examples and see how they go. So I'm looking at number 3 right now. You will notice that 2 and 4 are already done. So try those out by yourself. See if you get the right answer. See if you get the same answer. So number 3, we've got a negative sign. So these are the things you got to watch out for. So distribute this negative sign to every single one of these things. So a lot of times, well actually most of the time, all the time, what I like to do is put a little plus here and then throw a negative sign in front of each one of these just so that I don't forget that they are in fact negative. Other than that, combine like terms, let's do it. So 5k cubed, there are no other cubes. So I'm just gonna write 5k cubed. Looking for squares, we're gonna have negative 4k squared. Looking for just regulars, we've got 2k, negative 2k, so that cancels out, convenient enough. And then we just have minus 17. And a little bit of word problem, not much, but just anytime it says subtract this, blah, 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 from blah, 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 the from blah, 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 blah goes first because you're taking this thing away from this guy. So this one goes first. So if we were to set this up and write it out, we're going to have 8b squared plus AB minus 2A squared. I don't care about those parentheses, but we're subtracting, and I definitely care about these parentheses because that negative sign is going to get distributed, and I want to make sure that I don't forget about it. So now we're going to distribute the negative sign, and it's just going to change all of my signs. And let's see here. I've got 2A squared and a negative 2A squared, negative 7A squared. We're going to have negative 9A squared. AB, 10AB plus 11AB, and then 8B squared, positive B squared, plus 9B squared. So just a little bit of terminology, nothing crazy.